In this video, we'll look at three examples of addition and subtraction of algebraic fractions. In each case, we're using numerical denominators. Before we start, let's keep in mind two basic rules for the addition and subtraction of any fractions. The first thing we must do is look for common denominators. That means we can go through and actually multiply the denominators together to get a common denominator, or preferably look for a lowest common multiple. We'll see this process as we go through these three examples. Once we've achieved common denominators for our fractions, we then need to add or subtract our numerators depending on the operation involved in the example. We'll also look at the process of how we change those numerators to adapt to the new denominators. In this first example, we can see that the denominators are 3 and 5. The lowest common multiple of 3 and 5 is 15, and we can go through that with a simple checking process by listing all the multiples of 3 and 5. Now when we change the denominators, what we do is we multiply the 3 by the 5 and the 5 by the 3 so that we end up with our common denominator of 15. But when we do that, we must change the numerators accordingly. And we can see here in the diagram we've multiplied both the numerator and denominator on the left by 5, and the right fraction, the numerator and the denominator, have been multiplied by 3. Whilst this might look like a different expression, we need to keep in mind that if we multiply a fraction, in this case the left-hand side, by 5 on the top and by 5 on the bottom, effectively the 5's can divide by each other and we're really multiplying by 1. So we really haven't changed the fraction at all. All we've done is establish common denominators. So when we go through this process, we're left with a fraction on the left that is 10p over 15, and the fraction on the right is 3p over 15. We can see that here in the next line of working. Now once we've established common denominators, we can put our numerators together, and the operation is to add them. And we do have like terms, so 10p plus 3p will equal 13p, and that means our resulting fraction is 13p over 15. In our next example, we have a similar problem, but this time we're subtracting fractions. We have denominators of 7 and 3. And by investigation, we can find that the lowest common multiple of those two numbers is 21. So we need to change the denominator of the first fraction by multiplying by 3. That means the same must occur to the numerator. And on the right-hand fraction, we must multiply the denominator by 7. So again, the same must happen to the numerator. Our resulting fractions are 15k over 21 and 14m over 21. Now we can subtract the numerators. But what we'll notice here is we have unlike terms. 15k minus 14m cannot be simplified because those terms are unlike. So that's the simplest we can make this fraction. In our final example, we have the subtraction of two fractions again, but this time the expressions in the numerator are slightly larger than they were in the previous examples. The two denominators in these fractions are 4 and 10, and by investigation the lowest common multiple of those two numbers is 20. That means we'll have to change our first fraction by multiplying the numerator and the denominator by 5. But there is a difference in this example. Notice how the whole expression in the first fraction has been placed in brackets, and that means we're multiplying everything there by 5. In a similar manner, the second fraction has been changed by multiplying the top and bottom by 2. But again, the numerator has been placed in brackets, so we multiply everything in there by 2. So if we change our numerators accordingly, what we'll notice is the fraction becomes 10g minus 5 over 20, subtract 2g minus 4 also over 20. Now we'll put our numerators together, this time all over a common denominator of 20. Now when we do this, we need to take care because we're subtracting the second fraction. So everything in the numerator of the second fraction is being subtracted. In other words, it's take away, in brackets, 2g minus 4. When we remove the brackets, it becomes take away 2g plus 4. And the reason why that is because we're taking away a negative, in this case taking away negative 4. To simplify this, we must now consider like terms. We've got 10g minus 2g, so that part of the numerator becomes 8g. And then looking at the numbers in isolation, we have negative 5 plus 4, and negative 5 plus 4 is negative 1. So our final answer will be 8g minus 1 all over 20.